Hello, welcome to the wonderful world of random sequencing, now known as the sequencing random numbers. We got a lot of material here. This is for roulette, and it's all relative to lotto too. I mean, the logic behind roulette and lotto are pretty much the same when it comes to the sequencing part of it. Uh, Folks, it is logical sequencing, and I'll show you that logic. And the sequences start from left to right. These are 6 per row here. It starts with the 7, goes to the 20, and then 32, and then starts a new line, and goes on and on and on. So anyway, there's a lot of ground to cover, and I'll be talking about this concept of the 100. That's a binary. That's a binary number. 100 is equal to 4, and that's right here. You can see that right there. 100, and also the 100 is equal to 8. That is symbolically speaking. Because, look at 8. 8 is a 8 that's lying down. So that makes right there. You can see that. And also, I will be talking about the 0011. That's right here. The 0011. That's equal to two numbers. It's equal to the 29, and it's a metamorphic sequence, and it's also equal to the 26. And the reason why is that, so here it is, 00 is equal to 29 and 26. I didn't put down 26 there, I should have. But anyway, so what if you were to put down like 00 and then put the 1 underneath it, what you would get is 2 nines. In other words, these are metamorphic nines. A 1 linked to a 0 there, that's a 9. And a 1 linked to a 0, that's a 9. So that makes 2 nines. What's 2 nines? 29 expresses 2 nines. 2 nines is 9, 9. And 9 plus 9, obviously, is 18. So that's that. And so it also corrects 6, because when you look at the 0011 right here, you don't know if it's 2 nines or 2 sixes. So it's equal to both. In other words, the 29 could answer this sequence, and all as well as the 26, because it's all relative speaking, So that covers that. Let's go on to what 29 represents. Now, the 29 is equal to 18. The 29 carries the statement 2 nines, which is 9, 9. And 9 plus 9 is equal to 18. So as you can see right here, this is the sequence that we're looking at here. I just simplified it here so you can see it better. Now, the 29 here, and so it's sequenced over here on this side, it's sequenced to an 8. So knowing that the 29 will sequence to a 18, in this situation like this, where the best sequences are in a half step away. So this is about the first right here is the very first place where it's a half step away. So at this point, this is where you want to bet on, say for instance, you're betting on 18 because 18 is equal to 29. But the only thing is that you don't know if it's going to be 18 or an 8. So in situations like that, you always want to play all 8s. That's playing it safe. In other words, you would bet 8, 18, and 28. Basically, there are only 3 numbers: 8, 18, and 28, because that way you'll cover all your bases. In this case, you could see that it did land on 8, so you're safe there by betting on 8, 18, and 28. And these themes repeat themselves. They repeat themselves over and over and over, as you can see right here. It on the 29, half step away from here, it landed on 00. Now that's something that you could cover your base on that, obviously, because this is what you call an 8. This is a metamorphic 8. So if you wanted to, you could also throw in a 00 in that sequence, if you wanted to, just to be safe. So in other words, even on this sequence, you could have bet 0, 0, 8, 18, and 28. Same thing with this one, I mean, it did throw a curveball, but that's okay. You can make up for this because now you know that this 0, 0 is going to link to a 1 to make 18, because this is your 8, the fallen down 8 linked to a 1. That's 18. So when these sequences happen, they happen in a little package like this. They don't usually spread out like this. They all kind of speak to each other like this right here. This 8 links to a 1 to make 18, right? So 18 is equal to 29. Same thing over here. You have a 0, 0. So you know that this 0, 0 is going to connect to a 1. Now, it did it here because it borrowed this one to make 18. And it also produced an 18 this way. So these themes, this is what you call a theme. And all these sequences eventually create a theme to be repeated over and over again. And 29, this is the way 29 expresses itself. So this is something that you should be very familiar with. In other words, the 29 is going to make an 18. So, and as you can see, if you would have played all your 8s here, you would have been safe. 8, 18, and 28. You hit on 8, boom. Now you know that this 8 is going to link to a 1. Now, remember that everything is beautifully packaged most of the time. So this is a nice little package here. It's all within here. It doesn't spread out much. So think that. So you know that this 18, this 8 is going to link to 1. So it's probably going to be over here someplace, right here, because of the 0, 0, obviously. Because once the 0, 0 is created, now you know that 0, 0 has to link to a 1. And if it links over here, it creates 18 over here. 18 is equal to 29, and 18 is equal to 29. And it created another 18. When it does that, now notice that it's already kind of going down, right? So now it has to create a 29 at this point, right? Because it can't just be creating 18, 18, 18. It has to speak to the 29. So at this point, when it creates the 18, it sequences to a 29. So the sequence is 18 is equal to 29, and 18 and 29 is equal to 18. So remember that sequence, and it's a very important sequence. Now we're going to get into this sequence here, which is see the 20 and the 80 and the 20. That's equal to 100. As you can see right here, you have the 28 and 0, 0, right? Now, one thing to note is that you have 80 here and 20. What's 80 plus 20? 100. And what Mother Nature does, is they put a 1 right there and borrow those double zeros, and it makes a 100 right here. So 80 plus 20 is 100. That's a nice little sequence. And whenever you, over here in the 34, whenever you get a 4 linked to a 0, you may get a 20-20 sequence. In other words, a 2-0, 2-0. In this case, it's done with the double 0 here. As you can see, 0, 0, and a 22. So this 2 links to a 0. This 2 links to a 0, so it makes 20-20, and that's equal to 40. So that's something that happens, You want to take that in consideration. And the thing about that is that if that's your hunch, in other words, if you believe that there's going to be a 40 equivalent, which is a 22, put in a 22 here, that's looking at these 2 zeros here, that makes 20-20. If that's your intuition, this happens to be the last place where it could actually make that sequence. So you want to take that in consideration. This is think of the 22, because the 22 linked to a 0, 0, that makes 20-20, which is 40. Okay, and now we're going to go over here, and this is the 18 0. See here, the 18. Now when the 8 that goes down right here to the 0, this expresses 80. So basically the 1 is just a statement of I am 80, 80. So when you got 80, you're going to have a sequence that's going to express 240s, probably 240s. because 240s is equal to 80s, right? So you have a 0 there. If you put a 24 there, now, like right here, this is the same thing, you got a statement that says 240s. What is 240? 40, 40. And 40 plus 40 is equal to 80. So this 80 is answered by this 24. It says 240s, and that is equal to 80. So let's go on to another concept here. Now, when you're looking at lotto or roulette sequencing, when you get numbers that are pairs like this, they create statements of equivalency. In other words, the 32 plus 32 is equal to 64, right? Let's see, 32 plus 32 is equal to 64, and you got 18 plus 18, that's equal to 36. Now, what's the common number that you have there? Obviously, it's the 6, right? Because the 32 plus 32 has 64, so there's a 6 there. And you have 18 plus 18, that's equal to 36, right? So this, notice how it's neatly packaged here, right? So the sequences that are going to be answered are going to be very close. So the 18 and 18 sequence answered by a 36. So 18 plus 18 is 36. So now this 6 is going to link to a 4. Now it's not going to link way over here. It's going to link over here probably because it's neatly packaged in one area. So you got 32, 32, and it's going to borrow that 6 here. So if you're not absolutely sure that you just have an idea that it's going to be a 6 of some sort, obviously you want to play 6, 16, 26, and 36. That would be a safe bet. I mean, I would recommend that. Because if you have 18 plus 18, that's equal to 36. But, Mother Nature throws their curveball. But at least if you play all 6s, you're going to hit on one of those. And in this case, you did hit on 36. So this is a very, very nice little sequence. And it's equal to 18 plus 18, which is 36. Now, one thing... So what's going to happen now is that that this 6 is going to link to a 4. In other words, the digits on the left-hand side are just statements that express this number, 64. So the value sequence here is 64, right? Knowing that the 64 is either going to be here, the 4 is going to be either here or here. In this case, it's here, and if that's your intuition, in other words, you want to bring in the sequence within this area right here. So this is the very first spot where this 6 could link to this cell right here. So obviously, this is a half step away, and this happens to be the very closest sequence that you could make. It could connect here and here and here, relatively speaking. But this is the very first spot. So I would assume that the 4 would link here because it's neatly packaged the way over here, you know what I mean? And so in this case, you will want to bet, assuming that there's going to be a 4 to make 64, right? Because 32 plus 32 is equal to 64. You want to play all 4s just to be safe. And that would be 4, 14, 24, and 34. If you did that, you're going to hit on 24. You're going to hit on some number. In this case, it was 24. So let's go on to another. And so this is the idea of when you're analyzing numbers, especially big numbers like 64, the value numbers are on the right-hand side. So this is the V's right here, value numbers. These are just statements. Now, in other words, this could be a 1, 2. A 1, 2 is an R statement. A 1, 3 is the I am statement. So these are statements that express the right-hand digits here. In this case, it's 64. Because 32 plus 32 has to be answered, and it's going to be answered by 2 cells. So we already have a 6 here, so you know that it's going to link to a 4. And so you want to think that it's going to be around this area in a nice little package. So this happens to be the very first cell that it could actually connect, because this is a half step away. This is but it could connect here and here, but ideally, because it's so neatly packaged, it would probably be over here. And so if you played 4, 14, 24, and 34, you're going to hit on 24, obviously, because that's what happened. All right. Whenever you have a hunch, that's the way you want to do things, you know. So now we're going to go on to see the, okay, so we're going to see this. This is the 100. That's a binary digit. If you get your calculator and you type in, you go into the binary mode, you type 100 and then hit equals, and then you go into decimal, it'll give you the answer of what that sequence is, and it would be 4. So 100 is equal to 4 in binary notation. So what happens is that every sequence, every number that is there is going to be sequenced one way or the other. Now, in this way, what happened here is you got a three sequence right here. Here's your 3, and then it's sequenced to 1 and 0, 0. But it actually, in reality, I mean, obviously, if we're starting with the sequences going this way, you know, it did it in reverse, so it would be 0, 0, 1. That's 4, right? So it's already playing off this 34 sequence, because if this is 1, 0, 0 and that's equal to 4, boy, you know that if you put a 3 right there, right, it would make 34. So this is actually 34. So this is a decimal 3 linked to a 100. That's 4, right, in binary notation. So you got 34, and that's equal to 34 right here. So every number gets sequenced. It's all an equivalent sequence. You know, that's the way it is, either in roulette or in lotto. Doesn't matter what kind of lotto game. You know, it's all relative. It's all equal to a number of some sort. Now we're going to go here. Okay, whenever you form a 27, you'll get a 14 sequence. Now, avoid that D there. I don't know why it got there. Anyway, so what happens is here we got a 27, right? 27 sequences to a 14 in a natural sequence. It didn't happen here, but what happens whenever you get a 27 like this right here, it will sequence to a 14, and it's going to, in other words, it'll do it by borrowing a digit from numbers. In other words, you have a 1 here linked to a 0, that's 10, and then it links to a 4. So that's kind of nice to know, because it will always create a 14 in one way or another. So knowing that this 27 is going to link to a number that represents 14. In other words, a 1 linking to a 0, that's 10, right? Now, if it links to a 4, it makes 14. And that's what happens in lotto, it happens in roulette. So knowing that, because you could see there's no 14 here, right? There's no 14 here, but you do have a 1 and a 0 right there. So now you know that either this cell or this cell is going to have a 4. In other words, even though you're assuming, maybe you might assume that it might be here, that's okay. But eventually it's going to have to be this cell, because this cell where it has a 4 is a half step away. So this is the last place where it could express that 4. And this is a situation where you're going to have to play 4, 14, 24, and 34, because they all have 4s. You do that, you're going to hit on one of those. So remember that no matter what, whenever you see a 27 like this is 27, right? Whenever you form a 27, you're going to sequence to a 14. Normally it would be like the number 14 right there, but sometimes, no matter what, it's always going to create a 14. So in this case, it borrows a 1 here and borrows this 0. That's 10, and then it goes into a 14. So I hope you enjoyed this sequence, and the sequences are in roulette and lotto are the same. Really, they're all the same. The language is the same. The logic is the same. There is logic here, you know. I know that we like to pretend that that it's just random, but random is logical sequencing, and I'm out to prove that. And I hope you enjoyed this video. There'll be many more like these, and we'll see you in the next sequence.